My dear friends, this is your science friend Srinivas. Today, I'm going to explain all about this cranky generator. So, this is basically to make you understand how a mechanical energy can be converted into electrical energy and then store the energy. And later you can use it whenever you want it. So this is very interesting gadget. So here is a handle. Okay. So if you run that handle, you turn that handle, then there's a gearbox here. Okay. So there's a gearbox here. So these gears are going to make this dynamo run. Okay. So there's a dynamo here. So once the dynamo is running, so the mechanical energy is getting converted into electrical energy, and that will come through this cable, plus minus red cable, and that will go to this circuit board, electronic circuit board, where that is getting controlled, okay, so that the battery won't go bad, so that perfect charging will take place in this battery. Okay, this is a battery. You understand? So, while you are walking, you can keep, turning this handle, or whenever you are free, you can turn that handle, or whenever you are in need of electrical energy, okay, you can keep turning that handle. So, this is a handle. Okay, you can take out from this and then keep it in 90 degrees and then start running. So, the reason I'm explaining all about this tinkering, today's tinkering, this cranky generator. This is very useful gadget. While because there are sometimes floods. Recently we have seen massive floods at Kerala. So what happens during the flood times? The local electrical distribution system will get fail. I mean, they generate power and they step up the power to 220 kilovolt line. And they are very strong. The 220 kilovolt distribution lines are very strong. And somewhere they will step down to 132 kV lines. And later they will further step down to 66 kilovolts. And then further they will step down to 33 kilovolt. And then at mandal level, you have a substations, 33 kV by 11 kV. So from there, the 11 kV will get distributed to all your streets of villages and the towns everywhere. And then you will have a further step down transformer, the cylindrical one, almost for 10-15 homes, one transformer, okay. So that will have the primary of 11 kilovolts, and then it will step down to 230 volts AC, that will come to your home. So what happens during this natural disasters like, flood times and all? So the distribution systems at villages and then, this 11 kV distribution will get failure. So your 220 volts is not going to be there. Though that 220 kilovolt is producing at power generating stations and all. But however, in the distribution system at maybe 11 kV you will have problems. Okay, because so due to which the 220 is failed. 220 volts when it is failed, then you are in dark. That's what happens usually. Okay, a lot of cyclone times and then this kind of. So that's where you need to have an alternative system. So a lot of people have the solar, backup, but in sometimes solar will also have some problem. So that's where, so you can use this kind of cranky generator. Very handy and cranky. You can give a crank. The cranky, the name given to this is because there's a crank inside, so you'll be rotating that crank through the handle, this particular handle, okay. So now, once you rotate it, I explained, that your mechanical energy, so however you get the mechanical energy through your hand and all, because of your breakfast or lunch or dinner, whatever, it goes into your stomach, that will give some muscular energy through your body system. So that will help you. But now the thing is, what happened, so this is a beautifully designed product. And I must thank to my best friend Mr. Nandakishore Velcheti. The reason behind I'm thanking him, he brought it from United States and used it for a long time, almost for 10 years. Then suddenly what happened, recently last week I been to his place and then he gave it to me, this one. He said, you tinker it, somehow it is not running. It's almost struck. This handle is struck. And then I said, okay, let me check it out. So last week when I opened up this particular thing, all these particular gears and all, and I found everything is fine. The greasing is nice, the gear wheels are nice, the gear teeth are nice, the circuit is nice, everything looks like very nice. But only the thing, because it is not allowing the handle to move, because the motor was jammed, this motor. This is the culprit. This is the, no. So here what happened, you see, I can show you this way. See, this is the motor I have removed. I mean, I cannot say this is a motor. So it's a dynamo. Okay. This dynamo was removed from this cranky generator. Okay. From this, here, this location. Okay. So, why is that I'm just mentioning about all this? So, because of it is so badly rusted. Okay. So, it got jammed. So it was totally struck. I can show you some pictures I have taken while I'm opening this particular dynamo. I have taken some pictures. I'll show you how badly it rusted inside and how it was struck. Okay. Then after I opened up this dynamo, I wanted to repair it. Because you know that I'm a tinkering man, so I just wanted to show you, because in my childhood days I enjoyed, lot much all about this kind of tinkering. So that's where in my childhood I always wanted to understand how the things work, So I used to have a lot of questions like what is this winding, what is this a magnet, how electromagnet works, why this commutator and the carbon brushes, why they are giving a additional extra battery connection, then only why this particular motor moves, this DC motor, all these kind of various questions I have. The most interesting fact I wanted to share with you all today is, though it is a DC motor, but we also call it as dynamo. Because this particular DC motor acts as a DC dynamo. Because when it is in DC, so if you give mechanical rotation to this armature, okay, and then in a magnet field, and there is electrical, EMF induced in this winding, the copper winding, okay. So if you have a connections from the copper winding through this particular, you can see there is a carbon brush connections here. I can show you a little bit closer. See, in the center you can see some carbon brushes. So from there, there's a copper leaves. Okay, copper leaves are going to be like this. You can see here in this, I can show you on the other side. Okay, see, only one leaf is there. The other one got rusted and it got broke. Now only one you can see. Okay, so I can show you this way also through my I can show you the way it can move there and here. You see, this one, okay. So the other side also is supposed to be there because of the rusting, and that carbon leaf is no more. It has become like a powder. It has come out. So why is it I'm mentioning about all this? So when that connection is no more getting connected to my armature, carbon bush area, this area. Okay. See, I'm trying to go for a little closer. See, in the center. Okay. Okay, so you see there's a brown color bush, and then on that there's a carbon brush. Okay, just after the black rubber bush and then the brown color, after that there's a carbon. There the connections are going to be there. But however, So finally, what I wanted to say, this particular, though it looks very nice, this particular armature, okay, looks very nice. It is really nice, okay, it is really nice, no doubt. So here is the carbon brush. So here the connections will take, all these winding connections will come here to this particular. So the issue is, so I thought of repairing this dynamo, but however I could not make it work because of this particular other brush connecting leaf is not working. So finally I wanted to remove and replace with other dynamo. So I can show you, I have a lot of DC motors, so that I can make them, I can use them as a DC dynamos into this, in this gadget. So I can show you in a picture. I have taken a picture yesterday with all my collections. So one got connected with outer diameter of 24 mm, because this also has got 24 mm outer diameter, because I have checked it up with my vernier calipers. Okay, so I can show you here. So we need to check that way. Okay, so I have checked it up. See, you can also check it up this way. So see that reading 24 mm. So fortunately, I too have in my collection one 24 mm outer diameter matching the holes and all. So, but the screws are not matching, because these screws, the black ones, are not at all going into my my own dynamo, which is now replaced. So yesterday I went to Rajahmundry. I spent near about 3 hours and visited not less than 10 to 15 various shops, electronics, motor shops and whatnot. But I could not find this kind of dynamos or the screws or whatever. Then by the time I reached some service centers, repairing fellows, then by the time it is 8 o'clock and none of them available. So I said, okay, let me do something. So today morning, suddenly I got an idea, oh, this kind of small screws might be there in one of my unused camera. So I removed 2 screws from that camera, used it and tinkered, and then replaced all the gears properly. And I tested by giving a crank, and they are all moving now. Now, I had to just pause this video here and then do a little more tinkering, checking the voltage with my multimeter like this, digital multimeter and all. I want to see the outputs by giving some rotation to the crank and all, and see the readings and all that, loading and current and battery capacity and all that. So I'll add that information into this video little later. I mean, maybe after another half an hour also. Okay then, till then stay tuned. Bye-bye. Okay, now I have connected the dynamo output to the circuit board, and from the circuit board to the battery. Now I can give crank and then see how the charge is going on. Good. Okay, my dear students, my dear friends, see now what I am doing is, I have this digital multimeter. So I want to measure the DC voltage of my dynamo. Okay. So what I am doing, because while I am giving this cranking, I cannot connect my multimeter probes to my dynamo output, which is going to get connected to the circuit. That's why I am using these crocodile clips. Okay. See, this is how I have connected these crocodile clips. So one crocodile clip. Okay, now the other crocodile clip I will be connecting to one of the probes of my multimeter. Okay, now I'm going to connect the crocodile clips onto the circuit board where my output of dynamo is coming. Okay, yeah, I have connected. So now I have this crank. So I know you have eagerly waited for how the crank works. You see, when I'm running, when I'm turning this crank, all my gear wheels are moving inside. and because of the gear wheels, and everything is moving properly. And you can see, there's a voltage coming out around 3 volts now. So if I turn it more speed, that means the dynamo output voltage is directly proportional to the RPM given to the dynamo, the number of revolutions per minute. Okay, more the turn, more the voltage, right? Okay, now that is showing minus, right? Stop, and again slowly I am giving, that is minus, right? Okay, doesn't matter. Now I go on to other clockwise, this is anti-clockwise direction. Now it is positive. Doesn't matter as long as some direction. So this circuit is special. This particular circuit is special. So this will convert that either the direction into unidirection and then charge the battery. Okay, now you understood how this cranky generator works. So thanks to my friend Mr. Nandakishore, who gave me to tinker this. Okay, I wanted to make him happy by again making it work. Okay, so I got the opportunity in between to show you how the tinkering works, my dear friends. Okay, this is very interesting. Now I can give some more turns like this, and finally I can store all my mechanical energy into this battery as electrical energy. And whenever I want, I can, switch on this and see the lights comes out. That and all, I'll be finally closing with all this. There are so many things, parts. There are so many parts. Okay, so there's a lens here, there's a torch here, this LED, LEDs. All there are so many small parts are there for fancy. So, and this is the lens. Okay, all these things I'll be fixing back, and then this is a reflector also, wonderful reflector also, so that all the LEDs light will be focused onto a single place. So, thanks for watching, my dear friends, and this is your science friend, Scientific Srinivas. On this Guru Purnima day, I have tinkered this. So, enjoy tinkering, happy tinkering. Thank you, bye-bye, signing off, your science friend Srinivas. Take care, bye-bye. And I think actually one more point I forgot. All my NRI friends, they all can collect all such kind of various gadgets they have used during their time. So later, when they are not using, if such kind of toys, kind of electronic toys or whatever, if at all they can bring it out to India, and then if we work together and then giving them to all my various tinkering labs, and then make them understand the children enjoy tinkering. That's called toy tinkering. Okay, so we need to give them that opportunity to work with the toys to work back on, like the way I did this tinkering. Okay, so that's where they understand a lot many parts in depth, in detail, so that they enjoy. Once they make it work, the happiness is more important. So with that happiness, they grow more practical. Okay, so anyway, this is a new thought I'll put in front of all my NR friends. Let's see how they come forward to make this concept work. Good. Happy tinkering once again. Thank you. Signing off, your science friend Srinivas from scientificstudents.com. Okay, my dear students, my dear friends. So finally, our cranky torch, handy torch. Now totally I have assembled back. Okay, see how beautiful is this. So I am loading my energy. I am converting. Today morning I ate 4 idlis. So every idli has given me 150 calories. So almost 600 calories went into my stomach. And now my body is converting all that 600 calories into muscular energy. So I have a lot of muscular energy now. So all that muscular energy I am burning, by running this particular handle, the crank, So I am giving cranking. This is called cranking. Okay. So when I am giving cranking, the energy is getting loaded in my battery. Okay, the torch. So it doesn't require any external electricity to charge this. No sun energy is required, and no photovoltaic energy is required, and no light energy is required, converting into electrical energy and all. and no regular charge is required, regular electricity is required, nothing is required. So in emergency situations, so we can keep giving this, for 10 minutes, and then the battery will totally get charged into fully charged condition. So after that, you can just use so this one you can again keep it back, because when the battery is fully charged, we don't need this handle anymore. We need to use that as a charge. Okay, so I need to give more. Okay, so how interesting is this? Oh, very beautiful. All the 3 LEDs and with a reflector, very powerful. Okay, we can use it in emergencies. I think we need to have, every student can make one such here. Okay, so what I can tell you, Skill India from School India. So made in India, make in India, Skill India, School India. Jai Hind, Jai Bharat, Jai Jai Vignan, Jai Jai Tinkering, happy tinkering. Thank you, all my dear tinker. Let us do tinkering more and more. I means not only import India. Okay, now and then we'll make export India, my dear friends. Okay, productive India, towards productive India. That is all possible once you know how the basics works, how the tinkering works. So that's how we need to tinker many things. Let us do a lot of tinkering more. Day by day, every day I'll come forward with a new different tinkering here and then. So you all will be enjoying all that tinkering. Happy tinkering. Bye-bye. Signing off, your Scientific Srinivas from scientificstudents.com. Once again, I personally thank my best friend, my brother, Mr. Nandakishore Velchetti, for giving me this opportunity to work with this tinkering. Okay, he gave me so many gadgets to tinker. We'll do all that one by one. Okay, let's do.